Yes. So one is the master slave flip flop. D flip flop is available. One topic is the master slave. D flip flop. Okay. So basically before that one, D latch. Okay, we already discussed about the D latch. This one. Okay, if we connect with the enable pin, so this is the D latch. So if we go with the D latch again, so this is the D clock, Q and Q bar. Okay. Now thing is that if we represent a clock in a simple way, that is the level trigger. Okay. And if this one will be represented in this way, so this symbol basically represent the S trigger. We know the latch is level triggered, so we are not representing this one. Okay, if it is a flip flop, so we should represent that one. D, Q, Q bar, and that is clock. Okay, not for D, for all flip flop. Either it is SR flip flop, so S and R. Okay, if it is a flip flop, this one, if it is a latch, it is S and R block. Okay, so don't be confused with that one. If no symbol is that one, that means it is a latch. So it is a SR latch. That is SR flip flop. Okay, so this is the D latch. Now if we draw the timing diagram for D latch, so if we have a clock pulse, this one, this one. Okay, this is my clock pulse. This is the rising edge, this is the falling edge, positive level and negative. Now if my D data will be moved like that. Which I just mentioned 101010101000011. Like for example, this is my D data. Okay, if I apply that one, so what is going to happen is that if it is a latch, or we can say it is a positive latch, so that means any changes when the clock pulse having the positive level will be reflected in the output. Okay, and the changes between this negative level, there is no change. Okay, data is no change or data change. So that means if we are saying this is the Q, this is the negative, so we don't consider what is the D. So any particularly value we have be D till that one. Okay, now when the clock will be the positive level, so any change in the D will be reflected. So it is a 1, 0, 1, 0, 1. Okay, so 1, 0, 1, 0, 1. Now after that, When the negative label is appear, so there is no change. Okay, again the positive label is appear, the data is 1 1 0 0. After that, again the positive level, negative level, no changes in the data. So this is the final output queue. This is the final output queue. So we can design this latch also with the help of multiplexers. Okay, also with the help of multiplexers. So from this diagram, we can say my Qn plus 1, the data is D when clock is positive level. Okay, so which we apply at the D, that will be reflected as the output when clock is positive. Okay, and Qn plus 1, where the data is no change, or we can say it is Qn when clock is negative. Okay, so we can implement this one in this way. We have a 2 cross 1 mux. This is clock. Okay, when clock is 0, a negative level, the data is Qn. So when clock is 0, I naught is selected. When clock is 1, I1 is selected. So I1 is, we apply the D. So when clock is 1, we are getting at the output Qn plus 1 is equal to D. And when clock is 0, the output is just previous one. If we apply the feedback path in this way, so the output will be same. Okay, when clock is 0, the output is same. Clear? So we can implement with the help of this one. Now again, mux, if we are talking about the mux, so mux is what? Simply if we say that it is a mux, 2 cross 1 mux, I naught, I1, S. So what is the output equation for this one? I naught S bar plus I1 S. So we can say that there are two inputs. One is the I naught S connected with NOT gate, that is ending. I1 with S connected with AND gate, ending, and again ORing. Okay. So basically this is my mux. This is my mux. So we are getting I naught, I1. Okay. Both will be commons. We provide as a S. Okay. Now S is basically select line is clock. So we can say the clock. Okay. I naught is connected with the feedback. So we connect this one with feedback. Okay. And I1 connected with D. So this is my D flip flop internal diagram. Okay. This is my D flip flop internal. Sorry, D latch, not flip flop, D latch internal. Any doubt? Yes, any doubt?
No, sir.
Okay. Now, the next is master slave. Okay, master slave D flip flop. Now, in the case of master slave, what will be happening is that we are using two D flip flop. We are using the two D flip flop. Why two D flip flop? One will be behave as a master and one will be behave as a slave. Okay, so we have one latch D clock Q and Q bar. Again, we have a D clock Q and Q bar. Okay. Now, thing is that both flip flop will be work if it is work in a simultaneous. Simultaneously means in one clock, in particularly clock, this will be work. Then second clock, this will be work. So that means we are getting the output after two clock pulse. Okay, after two clock pulse. So this is the problem. So what we can do if we want that both flip flop will work in a same clock pulse. Okay, in a same clock pulse. So we require that one flip flop will be work on a level, positive level, and one flip flop will be work on a negative. Okay, one flip flop will be work on a positive level and one flip flop will be work on a negative level. So that means we are getting the output after every clock pulse. Otherwise, what will be happen? If we change any input, if we change any input, like if I change D from 0 to 1, okay, so in the first flip flop, first clock pulse, this output will be appear. Now this output will be go into the input of second one. Okay. Now second clock pulse is applied. That means this data will be appear at the output. That means if we do any change in the input, we are getting the output after two clock pulse if both clocks are same. That is the delay. Okay, so that is the delay. So what we do? We are going to remove this delay. So what we are doing, one thing is that we are connected. Yes. Okay, we are connected this way. So what will happen now? In the positive, this clock will work. This particular flip flop will work. In the negative, this flip flop will work.
Sir, can you explain this again?
Yeah. The thing is that both will be clocked. Okay. We are taking only the both two latches, D latch. Okay. So the latch is basically the level triggered. So if we apply the clock directly, if we connect the clock both, okay. I'll just take a timing diagram. Just say that Q1 and Q. This is my clock. Okay. Now at first clock, this is the first, second, third, fourth. At first clock, I just apply the D as a 1. Before that one, any D. Before any D. After the first clock, I just apply the D and change it. Okay, so this is my D. Okay, now what is Q1? Level triggered. So in this level, any changes in the D will be appear. So before that one, any data, but when this particular level is positive, D is 1, that will be maintained. Okay. When the level is negative, any changes, no effect, it will be continued. Second positive level, what is D? 1, that will be continued. Okay, it's not fine. Just continue. Continue here, then change. Okay, and if it is 0, so it will be continue 0. Now the third clock positive edge, if it is 0, so it will be 0. Before that it will be 1. So before that it will be 1 and continue. Next, it is 0. It is 0 here. Or I can say that 0. Okay, changes, no effect. Again 0. After that it will be changed to 1. Sorry, 0, 1 and 1. This is the Q1. Okay, so in a positive clock, any change in D, it will be reflected in the output. In the negative clock, negative level, if any change in the D, no effect. Same previous data will be transferred. Okay. Now, this Q1 applied to this D after next clock. Why? Because one clock it will be take to apply here. After that next clock, what is the data? That data we will apply at the input and we are getting the output. Okay. So if I am taking this is a Q2, so Q2 no effect. Why? Because we don't know what is the data. Yeah. Okay. Now this data apply on a second clock. So second clock and data is this one. So this data will be go high. Third clock high, then low, then continue. Fourth clock data is this way. Continue. So basically you can see that it will be shifted. This particularly Q1 will be shifted by one clock. Okay. So data will be shifted by one clock. So this data will be shifted. Q1 data will be shifted. So here the Q1 will be started from here. Now in the second case, the Q1 will be started here. Clear? Why it is shifted? Because we apply the same clock. So first, when the first data is out, then for the second clock, that this data will be applied on the input and we are getting the output. So that means we are getting the final output from that one after two clockers. One is from this one and one is from this one. Is it clear?
Okay, sir. Yes, sir.
To avoid this condition, what we do, we just do one change is that we apply a negative. Okay, negative clock. Now, if we apply the negative clock, so what is the effect of that? Okay, if I am talking about the Q1, so what is Q1? For the positive level, the data is same. For the negative level, no change. Again, for the positive level, for the negative level, no change. Again, the positive level, the data is same. If it is 0, so it will be continue. Continue. Again, for the positive level, the data is same. If it is 1, sorry, if it is 0 after that one, sorry, 1 for a short duration, then 0, 0. Okay, again for the negative level, no change. For the positive level, if it is 0, 0, then switch to 1. Then again for the negative level, no change. Okay, so we can say that this one is the D and this one is Q1. D, Q1, D, Q1, D, and Q. Okay, now this will be the input for the second one, and second one will be work on a negative level. So here is a negative level. Here is a negative level. The negative. Okay, so what is Q2? Before this negative level, we don't know what is the data. So we express that we don't know what is the data. Okay. When this negative level apply, the data is 1. Data is 1. Till negative, this is data is still continue. Okay. After that, the positive level is arrived. So no change. No change. Okay. Then again, the negative level arrived, the data is 0. So we change the data up to 0. Okay. Till here, hmm, sorry. Hmm, okay. After that, this data is changed, but this is available in D1, so no change. Okay, when the negative clock is applied, this is the data, no change. When the negative level is applied, the data, so this is fine. Okay. So D is the input for first flip flop. The first flip flop output will change when the label is positive. Okay. So we are getting the Q1 as a output. So with first flip flop, this is the output, this is the input. Input and output. Now for the second, what will be happening? This will is the input and this one is output. Okay. Now you can check with the output D2. The only transition is possible where negative edge is appear. So if this is the negative edge, what is D? D is 1. So we consider as a okay. When the second is appear, what is D? D is 0, then 0. Third, what is D? That is again 0, so we contain it as 0. At the fourth, what is D? D is 1, so we are getting the. So we can see is if we are using two particularly latches in a way that both latches are connected in a cascade form, the output of first will be input for second, and the clock pulse is opposite level triggered. Opposite level triggered is that if first one is the positive, second one is negative. If second one is positive, first one is negative. Okay, so that is if we are connected two latches to latch in cascade form. Okay, output of first will be the input of second. Okay, clock are opposite trigger. That particularly configuration will be a flip flop. Okay, because if we are using this configuration, my output will be changed only the edge. My output will be changed. This is the there is the edge. The output is changed edge. The output is constant on the basis of data, but output is changed on this edge. Okay, so my output is only changes on the edges. If output is changes on the edges, that means it is a flip flop. That means if we are connected two latches that are at different level triggered, so the combination of this one will be become a as trigger, and that as triggered is flip flop. That's why we called as a master slave D flip flop, not a latch. Okay, any doubt? Similar way, if I am using the first as a negative, I just take one more example. This is my clock. Hmm, Okay. On the line. I'm taking this to the positive edge. Okay. Now we are creating the latch. So one first latch is basically negative. First latch is negative. So we are connected the clock. Second latch is positive. We directly connect the signal Q and D. This is D, Q bar, Q, Q bar. I just say this is the Q2, this is the Q1. Okay. Now my data is okay. So according to this one, what I expected is my data should be changed on a positive edge. Why? Because we are connected to particularly latches that are cascaded. Output of first will be interface for the input of second, and clock are different level trigger. Okay, so we are getting what are the output. Expected output is Q expected is we check what is the in D at positive clock, positive edge. So if this positive edge, the D is 0, so we are getting is 0. Okay, till next. Second clock, D is 0, that means Q is 0. Third, D is 1, Q is 1. Fourth, D is 0, Q is 0. Fifth, D is 1, Q is 1. And sixth, D is 0, Q is 0. So this is my expected. Now we check that either my Q2 is equal to the expected or not. So I just take a first Q1. Okay. What Q1? Q1 is negative level trigger. So negative level is here. So we are getting from 1 to 0. Okay, if D initially it is 0, so we are getting 0 for this one till this one. Now this is the negative level, the data is from 0 to 1. In between them, no change.
So in negative region, it follows the D.
Yeah, in negative region, because first clock is the negative level, na?
Okay, yes, sir.
So in the negative region, it follows the D. In the positive region, the data is same, no change. Okay, again the negative region, it follows D. Okay, in between them, in the positive region, maintain as the same. Okay, in negative region, the data is D is followed by the D. In the negative region, it is same, no change. Again, it is a positive region, no change. In the negative here, it is
So there should be
whatever.
one more line also, right?
Yeah,
There should be one more line, right?
yeah, one more line, one more red line is there. Okay, any doubt in the Q1?
No, sir.
Now, for the second flip flop, the Q1 is the input. This is my input. Now, it will be managed that when the clock is 1, any output is followed by the Q1. If the clock is negative, no change in the output. So if you see here, when clock is 1, the data is 0. So what is Q2? The data is 0. Okay. In the negative, as no change. Again, the positive, the data is 0. Okay. Now for remember that for the Q2, this is your data, input data, not this one. Okay. For the negative, no change. Again, for the positive, the data is followed. So the data is 1, that will be followed. For the negative, no change. Continue. Again, positive data, this one. This is my data. Okay. For the negative, no change. Again, for the positive, the data is followed. For the negative, no change. And so on. Now, can you see that Q naught is simply to the Q expected? And what is Q expected? Q expected is the positive as trigger. And Q2 is sorry, initially that is a negative level triggered, then followed by positive level triggered. Okay, and you can see that Q2 is equal to Q expected. That means if we use two different level triggered flip flop and connect it in a cascade form, it will be become a edge trigger device. So that means master slave D latches The combination of these two will be a flip flop. Clear? Any doubt? So
No, sir.
negative level triggered, then positive level triggered is equal to positive as trigger. And opposite of that one is positive level triggered followed by negative level triggered is equal to negative as triggered. Okay. Now in the lectures, professor say one more thing is that if we are creating the latch, here this is the clock, okay, this is the I1, I1 is D, this is I0, I0 is this one, okay, and that is Q1 plus 1. So we already know if we connect one NOT gate with NOT gate, it behave as a buffer. Okay, so what should we do? We connect one NOT gate here and connect one NOT gate here. Feedback these two. Okay, now if output is NOT gate, so that means we require a NOT gate also here. Okay, and that NOT gate is basically used for the stability. Okay, for the stability. So that is about the master slave. Okay, now tri-state inverter based delatch. Okay, so we already discussed that tri-state. What is a tri-state? We know that for the inverter, if we apply the 0, we are getting 1. If we are getting 1, we are getting 0. Okay, we introduce one more state. Okay, and for one more state, we are introducing one more terminal, that is the control. Control, or sometime it is saying something different. Okay, so control, or it is enable also. Okay, so accept 0 and 1, or basically low and high state. There is one more state that is called the high impedance state, that is Z. Okay, so if we have a 2 plus 1 mux, this is I0, this is I1, we have clock, we have connected as a Q and plus 1, D. Okay. When clock is zero. When clock is zero. So my Qn plus one is Q. Okay. Qn plus one is Q. Why? Because if you apply zero here, so it will be go one. Again, if clock is zero, so I naught is selected, I naught is one, so we are getting output as a one. Now this one, it become again pass through the NOT gate, so we are getting zero. So my Qn plus one is similar to the Q. Okay, and when clock is one, we are getting Qn plus one is equal to D bar. Not D bar. We are getting D bar here. So if clock is 1, D bar is the output and Qn plus 1 is D. So D double bar, that is D. Or in another way, I can say that if it is Qn plus 1, I just say that Qn plus 1 bar. So when clock is 0, Qn plus 1 bar is Qn bar. And when clock is 1, Qn plus 1 bar is D bar. Okay, we are taking the complement for both. Okay, now we have a tri-state inverter. So we know that if it is a D, it is a Qn plus 1 that will be controlled with the enable pin. So if I write a equation for that one, so I can say if enable is 0, my Qn plus 1 is high impedance state because that device is not working. So either we apply D is 0 or either we apply D is 1. Always we are getting a Qn plus 1 is 0. Okay, if enable is 0, if we apply D as a 0 or D as a 1, Qn plus 1 is always 0. Okay, that means I apply anything on the D, it is not pass on Qn. Okay, and when it is not passed, that means there is no connectivity between D and Qn. Otherwise, if there is a connectivity, that means if D, so we are getting Qn. But if D apply the D that is not pass on Qn, so that means there is no connectivity between D and Qn. And if there is no connectivity, we can say that it is a infinite or open circuit. Open circuit or open path. Now, what is the meaning of open path? The resistance is infinite. So that's why it is called the high impedance. Okay, that's why it is called the high impedance. So if enable is 0, we are getting Qn plus 1 as a Z. And if enable is 1, we are getting Qn plus 1 is D. Not D, D bar. Okay. So if we compare these two equations, these two terms, one is this one side is this one, and second side is this one. So we can say that enable is equal to clock. Okay. The work that enable do, that will be the same work will be clock do. So we can say that this is my clock. In place of enable, I use the clock. D Qn plus 1. Okay, now clock is 0. Qn plus 1 is Z. Okay, high impedance. So we are getting a 0. Either we apply the input 0 or 1, we are getting always 0. And if clock is 1, Qn plus 1 is D bar. Okay, now this circuit clock is done. Okay, clock part is done. Now if you see that when clock is 0, here Qn plus 1 is Z, and here Qn plus 1 bar is Qn bar, or basically Qn plus 1 is Qn. Qn plus 1 is Qn. So we want that the data will be same. The data will be same. So what we do? We create a loop. Okay, we create a loop. So if D is 0, sorry, if clock is 0, we are getting a Q bar here. Sorry, Qn plus 1, that is D bar here, and we are taking one loop. I am saying that this is Qn plus 1, and that is Qn. That is Q bar and Q. Okay, and that will be controlled by the clock bar. Okay, now we check. Clock is 0, that means clock bar is 1. If clock is 0, clock bar is, so we are getting as a Q and bar is high impedance state. Okay, that means Qn is, okay, Qn is 1. Now Qn is 1, this flip flop work, so Qn bar is 0, and Qn bar is 0, that means with this NOT gate Qn is 1. Okay, when clock is 0, clock bar is 1, that means Qn bar is high impedance state. High impedance state, we can say we are getting the 0 output. And this is NOT gate, so that means we are getting Qn as a 1. Clear? Any doubt? Now this Qn will be passed through this clock, this particular NOT gate. This NOT gate will be working. Why? Because we are connecting a clock bar. So that NOT gate is working. So when 1 is applied, we are getting 0 here. And we know that Qn is 0. Qn bar is 0. Now this 0 is applied to this NOT gate, we are getting 1. So you can see that loop is going on when clock is 0. Okay, when clock is 0. But if clock is 1, that means clock bar is 0. Okay, now If this clock bar is 0, that means this is not working. So we are getting Qn is equal to D bar, and then D. So Qn plus 1 here, we are getting a D. Okay.
Okay, sir.
So that means we can create this particularly latch with the help of tri-state inverter also. There we are using two tri-state inverter and one is a normal inverter. The two tri-state inverter will be triggered with the opposite clock. One is the positive, one is the negative. Okay, so we can implement the latch on the basis of tri-state. So that is complete your week 9 content. Now go through with the video lectures once, then solve the questions. If you have any doubt, we can solve practice assignment in the Friday class. Okay. Any doubts?